Okay, let's see this MCQ. The diagram shows a network of resistors. Each resistor has a resistance of 6 ohms. Perfect. What is the total resistance between the network points X and Y? Okay, you have to calculate the total resistance between point X and Y. How will you do that? First of all, let's examine this combination. 6 ohms, 6 ohms, 6 ohms. So there are 3 6 ohm resistors connected in parallel. If there are same resistors connected in parallel, if you have same resistors connected in parallel, in order to calculate the total resistance across a parallel combination, what do? You take the resistance and divide it by the number of resistors. Sir, what do you mean? In order to calculate the total resistance of this parallel combination, you will take the resistance of one resistor, that is 6, divided by the number of resistors, that is 3. 2 ohms come out to be your answer for the total resistance of this parallel combination. Let's do the same thing for the next one. 6 ohms, 6 ohms, 6 ohms, 6 ohms, 6 ohms, and 6 ohms. The total resistance of this parallel combination will be equal to what? Resistance divided by the number of resistors. Resistance is 6, number of resistors is also 6. 1 ohm is your total resistance for this combination. Let's do the same thing for these 3 resistors. The total resistance for these 3 resistors will be what? 6. That is the resistance of one resistor divided by the number of resistors. 2 ohms is your answer. So the resistance between X and Y will be equal to what? 2 plus 1 plus 2, that is equals to 5 ohms as your answer. B is your answer. Simple as that. Let's further move ahead. A circuit contains a cell of electromotive force E and internal resistance R connected to a resistor capital R. The current in the circuit is I. Perfect. Which equation is correct? Okay, which equation is correct? Can you realize that the voltage across this internal resistance will be what? Current into the small resistor. And can you realize that the voltage across this larger resistor will be what? Current into the capital R. The total EMF of the battery will be equal to what? IR plus I capital R. Is there any option like that? There is no direct option like that, but if you see option A, this negative IR, if we take this to the right hand side, this will become what? E is equals to I capital R plus I small r. A is your answer. Let's further move ahead. A cell of electromotive force 3 volts, so your EMF is 3 volts, internal resistance 0.5 ohms, is connected to a variable resistor, a voltmeter and an ammeter as shown. Perfect. The resistance of the variable resistor is varied. The resistance of the variable resistor is varied. The reading on the ammeter and the reading on the voltmeter are recorded. Perfect. Which graph shows how voltage varies with current? Which graph shows how voltage varies with current? Very, very easy. Do you remember that EMF is equals to what? The voltage across this variable resistor, that can be represented as capital V, plus the voltage across this internal resistance, that can be represented with a small v. Perfect. Now what we can do is we can replace this small v with what? Current into what? Internal resistance, that is 0.5 ohms in this case. We have done this entire thing in the notes and lecture as well. I am just doing it again for the students that are new. So let's take this negative IR to the other side. EMF minus negative IR is equals to the voltage. Let's rearrange the equation a bit. V is equals to E minus V is equals to minus RI plus E. If you plot voltage on the y-axis, current on the x-axis, your y-intercept will be EMF. Okay. Out of option A, B, C and D, which one has a y-intercept of 3 volts, that is the EMF? Only option C and B. Only option C and B. A and D will get cancelled out because their y-intercept is not equal to the EMF. Okay. Now there is one more hidden trick. The gradient of the graph should be equal to what? Negative of internal resistance. Let's calculate the gradient of option C. Here you have x0, y3. Here you have x6, y0. Can you calculate the gradient? Gradient is equal to what? y2 minus y1, x2 minus x1. This comes out to be negative 0.5. which is equals to what? Negative of internal resistance. That's perfect. C is your answer. Let's further move ahead. Okay, let's see this question. Three identical cells each have electromotive force E and negligible internal resistance. The cells are connected to three identical resistors, each of resistance R as shown. Perfect. What is the potential difference across one of the resistors? Perfect. Can you see this positive terminal of this battery is connected to the positive terminal of this battery? Whenever like terminals of batteries are connected together, their voltages get cancelled out, or you can say their EMFs get cancelled out. Perfect. What is the remaining EMF? E. How many resistors do we have? 3. The voltage across one resistor will be E over 3. B is your answer. Let me check in the marking scheme as well. The answer to 5 is B. Let's further move ahead. Okay, let's see this. A battery of electromotive force 10 volts and internal resistance R is connected to 3 resistors of resistances R, 2 ohms and 15 ohms as shown. A current of 0.45 ampere is in the resistor of resistance 2 ohm and a current of 0.48 ampere is in the resistance of 15 ohm. Perfect. What is the value of a small r and capital R? Perfect. You have to calculate the value of a small r and capital R. How will you do that? The first and foremost thing that you can do here is calculate the voltage in this 15 ohm resistor. Can we do that? Voltage is equals to IR. I is 0.48. Resistance is 15. Can you calculate this? Yes, 0.48 into 15. 0.48 into 15. This gives you a value of 7.2. Perfect. This gives you a value of 7.2 volts. Perfect. Now, if this branch, let me highlight it, if this branch is getting 7.2 volts, according to the parallel circuits rule, this branch will also get 7.2 volts. This branch will also get 7.2 volts. Can you calculate the voltage across this 2 ohm resistor? Yes, voltage is equals to IR. Your current is 0.45 multiplied by the resistance, that is 2. 0.9 volts is your answer. What will be the resistance across this resistor? What will be, the voltage across this resistor R? What will be the voltage across this resistor R? Total voltage was 7.2. This small 2 ohm resistor is taking 0.9 volts. What will be the voltage across this resistor R? 7.2 minus 0.9. This comes out to be what? This comes out to be 6.3 volts. This comes out to be 6.3 volts. The current is 0.45 ampere. Can we calculate the resistance R? Yes. Voltage upon current is equals to resistor R. Voltage is 6.3. Current is 0.45. Your resistance R comes out to be what? 0.45. Your resistance R comes out to be 14 ohms. Perfect. So B cannot be your answer. D cannot be your answer. Let's calculate this small r. Okay. What will be the voltage across this internal resistor R? 10 minus 7.2, that is 2.8 volts. Perfect. What will be the current across this internal resistance? 0.45 plus 0.48. 0.45 plus 0.48. The current comes out to be what? Current is 0.93 ampere. The voltage is this. Can you calculate the internal resistance? Yes. Voltage over current is equals to your internal resistance. Voltage is 2.8 divided by 0.93. Your internal resistance comes out to be 3 ohm. A is your answer. Simple as that. The answer to 7 is A. I have checked in the marking scheme as well. Let's further move ahead. Okay, so let's start with this question. The diagram shows a cell of electromotive force 3 volts and internal resistance 4.7 volts. The lamp has a resistance of 9.3 volts. You have to calculate the power dissipated in the internal resistance. You have to calculate the power dissipated here. First of all, what can you do? You can calculate the current in the circuit. Voltage is equals to IR. Voltage is 3. Your total resistance will be equal to what? 4.7 plus 9.3. 3 over 14 ampere is your current. Can you calculate the internal resistance power consumed? Yes, I square into R. Current is 3 over 14. Square resistance is what? 4.7. The power comes out to be 0.22 volts. A is your answer. Let's further move ahead. A cell of electromotive force E and internal resistance R is connected to a variable resistor as shown. Perfect. The resistance of the variable resistor is gradually increased. Okay. So the resistance of the variable resistor is increased. Perfect. Which graph shows the variation of potential difference across the internal resistance with the voltage across the variable resistor? Perfect. So as the variable resistor resistance increases, what will happen? As the resistance of the variable resistor increases, what will happen? The current will decrease. Okay. As the current decreases, can you realize that there's a small v which is equals to what? Current into the internal resistance. As the current decreases, small v will decrease. Simple as that. As the current decreases, this small v will also decrease. Perfect. Now, which option out of these A, B, C, and D tell you that your internal resistance voltage is decreasing? Yes. Not C, not D, because in both of them, your voltage for internal resistance is increasing. If you analyze option A and if you analyze option B, in both of them, your voltage of internal resistance, small v, is decreasing. Perfect. Perfect, perfect, perfect. Now let's come on to the voltage across the variable resistor. EMF minus a small v is equals to the voltage across the variable resistor. If your voltage across the internal resistance decreases, what will happen to the voltage across the variable resistor? It will increase. So your capital V should increase, your small v should decrease. Any answers like that? Any answers like that? Any answers like that? Yes, option A. Your small v is decreasing, capital V is increasing. A is your answer. Let's further move ahead. A cell has electromotive force of 8 volts and negligible internal resistance. The cell forms part of the circuit as shown. Perfect. The reading V1 is 4 volts and the reading V2 is also 4 volts. Perfect. The reading V1 is 4 volts and the reading V2 is 4 volts. Perfect. What is the resistance of resistor R? You have to calculate the resistance of resistor R. If both of the voltmeters are giving the same reading, that means what? The resistance of both the resistor combinations will be same. Can you calculate the resistance of this parallel combination? Yes. R total is equals to R over N. R divided by 2. 2 ohms is your answer. The resistance of this parallel combination is 2 ohm. It is receiving 4 volts. What will be the resistance of this resistor to receive a voltage of 4 volts? 2 ohms. See, let me explain it again. Both the resistor combinations will have the same resistances because both of them are receiving the same voltage. Can you calculate the complete resistance or total resistance of this parallel combination? Yes. 4 divided by the number of resistance, that is 2. The total resistance of this parallel combination comes out to be 2. Simple as that. Let's further move ahead. A cell has an electromotive force of 6 and internal resistance R. An external resistor also of resistance R is connected across the cell as shown. Perfect. Power P is dissipated across the external resistor. Perfect. Power P is dissipated across the external resistor. Perfect. So for the original circuit, can you calculate the current in the circuit? Yes. The total voltage is 6. The total resistance is 2R. We have applied V is equals to IR. Can you calculate the current? Yes. 6 divided by 2R is equals to your current. This becomes 3. This becomes 1. The current in the original circuit is 3 over R. Can you calculate the original power? Yes. Power is equals to I square into R. I is what? 3 over R square into R. This comes out to be what? 9 over R square into R. R and R cancel out. 9 over R is your original power. Perfect. The cell is replaced with a different cell that has an EMF of 6 volts and negligible internal resistance. Okay. So now this cell will have no internal resistance. There will only be an external resistor R. Perfect, perfect. Okay. Can you calculate the current in the circuit now? Yes, 6 over R is your current. Perfect. Can you calculate the new power? Can you calculate the new power? Yes, I square into R. What is I? 6 over R whole square into the resistance R. 36 over R square into R. R and R cancel out. The new power comes out to be 36 over R. Perfect. Simple as that. Now there are no options like this here. Can you write the new power like this? Can you write the new power like this? 4 into 9 over R. Can you write it like this? Yes. 9 over R is equals to what? Your actual power P. So your new power will become what? 4 times P. D is your answer. Let's further move ahead. The circuit shown indicates a cell of constant internal resistance and external resistance are perfect. A student records the ammeter and voltmeter readings perfect. She then connects a second identical external resistor in parallel. Okay, so you are connecting a second identical resistor here. That is R. If you connect a resistor in parallel, what will happen? Your total resistance will decrease. As your total resistance decreases, your current will increase. Your ammeter reading will increase. Simple as that. So your ammeter reading is increasing. A and B cannot be your options. Perfect. As your ammeter reading increases, what will happen? As your ammeter reading increases, what will happen? Can you see the voltage across this internal resistance will increase? Can you see the voltage across this internal resistance will increase? Why? Because the current across the circuit is increasing, the voltage across this internal resistance will increase. What will happen to the voltmeter reading? The voltmeter reading V is equals to the EMF of the battery minus the small v. As the small v is increasing, the capital V will decrease, or you can say the voltmeter reading will decrease. So increases and decreases, C is your option. Let's further move ahead. A battery of electromotive force E and negligible internal resistance is connected to four resistors of resistances R1, R2, R3 and R4. Perfect. The currents I1 and R2 are in the resistors as shown. Perfect. There is a current I1 here, there is a current I2 here. Which equation is correct? One thing that I can think is the total voltage across this yellow highlighted branch should be equal to the total voltage across this blue highlighted branch. The total voltage across this yellow highlighted branch will be equal to the total voltage across the blue highlighted branch. Okay, what will be the total voltage across the yellow highlighted branch? Current I1 into resistance R1 plus R2. What will be the voltage across the blue highlighted branch? I2 into R3 plus R4. Is there any option like that? There is no direct option like that. But if you examine this point, if you examine option B, and if you take this value towards the left hand side, you exactly have the same equation. B is your answer. Let's further move ahead. In the circuit shown, the 6-volt battery has negligible internal resistance R1 and R2 and the voltmeter each connected has a resistance of 100 kilo ohm. Perfect. What is the current in the resistor R2? You have to calculate the current here. Let me zoom in a bit. You have to calculate the current here. I2. Okay. How can you do that? First of all, let's calculate the total current in the circuit. V is equals to I total into the resistance total. Perfect. What will be the total resistance here in the circuit? We have one resistor in series and two in parallel. Can you calculate the total resistance of this parallel combination? Yes, 100 divided by 2, that is 50 kilo ohms. This is your resistance of 100 kilo ohms. The total resistance will become what? 100 plus 50, that is equals to 150 kilo ohms. Perfect. Your voltage is 6. 6 is equals to I total into 150 into 10 raised to the power of 3. Your current comes out to be what? 6 divided by 150 into 10 raised to the power of 3. This comes out to be what? Let's calculate it. 6 divided by 150 into 10 raised to the power of 3. This comes out to be what? 4 into 10 raised to the power of minus 5 ampere. Simple as that. The total current in the circuit is what? 4 into 10 raised to the power of minus 5 ampere. As you move forward in the circuit, the current gets divided into two here. When the current goes into the parallel combination, it gets divided equally into two halves. Why equally into two halves? Because the two resistors are of the same resistance. What will be this current I2? This current I2 will be half of the total current. 4 into 10 raised to the power of minus 5 divided by 2. This comes out to be 2 into 10 raised to the power of 5 ampere. Perfect as that. Now, can you represent it in a format that is available in the options? Currently, 2 into 10 raised to the power of minus 5 is not available in any of the options. What can you do? You can say that this is a decimal point. Let's take it one place forward. 20 into 10 raised to the power of minus 6 ampere is your current I2. 10 raised to the power of minus 6 is equals to what? Micro. 10 raised to the power of minus 6 is equals to what? Micro. 20 micro ampere is your answer. I2 is your answer. A is your answer. Perfect. Let's further move ahead. Okay, let's see this. A cell of internal resistance R and electromotive force E is connected in series with a resistor of resistance capital R. The resistance R and EMF remain fixed. The internal resistance R of the cell changes over time. Perfect. Which graph best shows the variation of current in the circuit with the internal resistance? Perfect. So as the internal resistance will increase, as the internal resistance increases, your current will decrease. And as your internal resistance decreases, your current will increase. So you can see from this that they have an inverse relationship. Inverse relationship. Hence, C cannot be your option, D cannot be your option. Perfect. For an inverse relationship, you have a graph that is a downward sloping curve touching neither of the axes. Touching neither of the axes. Okay. However, in this scenario, option A will also be incorrect. However, in this scenario, option A will also be incorrect. Why? Because when current, when when your internal resistance is zero, you still have some external resistance in the circuit. Hence, your current will be equal to some positive value. It will not become infinity. Here, your graph cannot be the regular inverse relationship graph. Why? Because when your internal resistance is zero, there is some value of external resistance as well. That external resistance will generate a constant value of current. B is your answer. The answer to 30 should be B. And B it is. Perfect. Let's further move ahead. Let's further move ahead to the a battery is connected to a network of 6 resistors as shown. Okay. The potential difference across the five of the resistors are labeled on the diagram. Perfect. What is the potential difference across the resistor R? Perfect. What is the potential difference across the resistor R? Now, one thing to note here is that the sum of potential differences across this blue highlighted branch, the sum of potential differences across this blue highlighted branch, that is what? 4.1 plus 3.7 will be equal to what? Will be equal to the sum of potential differences across this yellow highlighted branch. Will be equal to the sum of potential differences across this yellow highlighted branch. 2.2 plus 1.2 plus the voltage in resistor R. 4.1 plus 3.7 will be equal to what? This will be equal to 7.8 is equals to what? 3.4 plus R. Perfect. Can you calculate the value of R? Yes. The value of R comes out to be 4.4. A is your answer. Let me check this out as well. The answer to 32 is A. Yes. Let's further move ahead. Let's see this. 4 different resistors are arranged as shown. A current of 1.5 ampere enters the junction at X and leaves through junction Y. What is the current in the resistor of resistance 30 ohms? This is a deliberately made diagram to confuse you guys. Let me simplify this diagram. This is a current of 1.5 ampere coming here. This is your 70 ohm resistor. This is your 70 ohm resistor. And on the bottom side, You have three resistors connected in parallel, 50, 30, and 60. This collectively will become what? 50 plus 30, that is 80. 80 plus 60, that is 140. Yeah. This is 140 ampere. And this goes out like this, 1.5 ampere. You have to calculate the current across this 140 ohm resistor because the current in series remains same. The current in the 50 ohm resistor will be the same as the current in the 30 ohm resistor, and it will be the same as the current in 60 ohm resistor. So let's calculate the current in this branch. How are we going to do that? How are we going to calculate the current in this branch? Now, what can you do here? You have 140 ohms, you have 70 ohms. You can calculate the total resistance 1 upon RT. 1 upon RT is equals to 1 over 70 plus 1 over 140. What will your total resistance come out to be? 1 over 70 plus 1 over 140. 1 divided by answer. This comes out to be what? The total resistance comes out to be 46.7 ohms. Perfect. The current is 1.5 ampere. Can you calculate the voltage? Yes, V is equals to IR. Perfect. Your I is 1.5. Your total resistance is 46.7, 1.5. This comes out to be 70. Yeah. The voltage is 70 volts. Perfect. So this branch will also be getting 70 volts. This branch will also be getting 70 volts. You have the voltage for this branch, the resistance for this branch. Can you calculate the current here? Yes, apply V is equals to IR. V is 70. Resistance is 140. The current is what? 0.5 amperes. B is your answer. The answer to 33 should be B, and B is your answer in the marking scheme as well. Let's further move ahead. The circuit diagram shows four resistors of different resistances P, Q, R, and S connected to a battery. The voltmeter reading is 0. Perfect. That means you are at a null point. That means you are at a null point. Which equation is correct? Which equation will be correct when you are at a null point? The resistance in P over the resistance in R is equals to the resistance of Q divided by the resistance of S. Can we manipulate this to form a correct equation? Yes. P into S is equals to R into Q. Any answers like that? D is your answer. Let's further move ahead. Two cells are connected to a load resistor of 3 ohms. The electromotive force and the internal resistance of each cell is shown. Perfect. Can you see this negative terminal of the battery is connected with the positive terminal? Hence, the voltages will get added up. 6 plus 3 is equals to 9 volts. Your internal resistance will be what? 0.8 plus 1.2, that is 2 ohms. Perfect. And you have a 3 ohm resistor here. Perfect. You have a total voltage of 9. Total resistance is 5 ohms. V is equals to IR. Voltage is 9. Resistance divided by 5. Current comes out to be what? Let's calculate it. 9 divided by 5. This comes out to be 1.8 ampere. C is your answer. The answer to 41 is C. Yeah, it is C. Let's further move ahead. Some resistors and a battery of electromotive force E and negligible internal resistance are connected in series as shown. Perfect. Which statement is correct? The EMF across each resistor equals the potential difference. No. The potential difference across each resistor. No. The sum of EMF across. No. The sum of potential differences across the resistor equals the EMF of the battery. I think the answer to 61 should be D. Yeah, the answer to 61 is D in the marking scheme as well. Let's further move ahead. Let's see this question. Three resistors R1, R2, and R3 are connected in parallel to a cell. Perfect. The currents in the resistors are I1, I2, and I3. Perfect. The potential difference across the resistor are V1, V2, and V3. The current in the cell is I naught. Perfect. The potential difference across the cell is V naught. Perfect. Which equation can be obtained by applying Kirchhoff's second law? Please remember that Kirchhoff's second law was for voltages. And which equation can be derived by applying Kirchhoff's second law? C. Voltage of the battery is equals to the V1 is equals to V2 is equals to V3. Now, can we check this answer as well. 62's answer should be C, and it is C as well. Yep, it is C. So, since the batteries are connected in parallel and Kirchhoff's second law was for voltages, the only reasonable answer here is this, in which we can see the voltage across all the branches is same. Let's further move ahead. Kirchhoff's first law states that the sum of current entering a junction in a circuit is equal to the current leaving it. The law is based on the conservation of a physical quantity. Which quantity is that? Charge. 64's answer should be A, and A it is. Let's further move ahead. Okay, so let's see this question. A circuit consists of a battery, a voltmeter, and 5 fixed resistors as shown. The voltmeter reading is 0. That means you are at null point. What is the resistance of resistor R? You have to calculate the resistance of resistor R. Let's first of all draw this circuit in a neat manner. This is a 2 ohm resistor. Can we resolve this parallel combination? Yeah. If two resistors are connected in parallel, the total resistance will be equal to what? Product of the two resistors divided by the sum of the two resistors. So this resistor will have a value of what? 8R divided by 8 plus R. Perfect. And then you have a 5 ohm resistor, and then you have a 10 ohm resistor. Perfect. This is connected like this in parallel. This is your first end of the voltmeter. This is your second end of the voltmeter. If you are at a null point, what does that mean? The ratio of the blue resistors will be equal to the ratio of the yellow resistors. Let's do that. 2 divided by 5 is equals to what? 8R divided by 8 plus R divided by 10. Perfect. You can multiply 10 to the other side. 2 upon 5 into 10 is equals to what? 8R divided by 8 plus R. This becomes 1, this becomes 2. Perfect. This becomes 1, this becomes 2. This comes out to be what? 4 is equals to 8R upon 8 plus R. Let's multiply 8 plus R towards the other side. 4 into 8 plus R is equals to 8R. Perfect. 4 into 8 is 32. 4 into R is 4R is equals to 8R. Perfect. 32 is equals to 4R. R is equals to 32 divided by 4. That is 8 ohms. D should be your answer. I am sure of that, but let's confirm it in the marking scheme as well. Yes, the answer to 65 is D. Let's further move ahead. Okay, let's look at this question. A cell of electromotive force E and negligible internal resistance is connected to a circuit. The circuit has currents I1, I2, and I3 and potential difference V1, V2, and V3. As shown, which equation represents Kirchhoff's first law? Okay, which equation represents Kirchhoff's first law? So what did Kirchhoff's first law state? What did Kirchhoff's first law state? Kirchhoff's first law stated that current arriving at a node is equal to current leaving the node. What are the current arriving at a node? I1. What is the current leaving the node? I2 and I3. So I1 is equals to I2 plus I3. Which one will be your answer? A is your answer. Let's further move ahead. The diagram shows a circuit containing two batteries connected together. What is current I? You have to calculate current I. How can you do that? Very, very, very simple. First of all, can you realize that the positive terminal of this battery is connected to the positive terminal of this battery? The voltages will cancel out. The final voltage will be what? 12 minus 8. 12 minus 8, that is 4 volts. Perfect. So you will have a 4 volts battery. What will be the internal resistance total? 1 plus 0.5, that is 1.5 ohm. 1.5 ohm. Yeah, this is your final circuit or simplified circuit. You have to calculate the current. V is equals to IR. Voltage is 4 divided by the resistance, that is 1.5, is equals to your current. 4 divided by 1.5, your current comes out to be 2.67. 2.7 is your answer. It is 71. The answer to 71 is A. Let's further move ahead. Let's see this question. A cell of negligible internal resistance is connected to a network of resistors. Can you see this is the same question that we have just did previously in the question? Try this out. Let me tell you the answer to this. The answer to this is D. Try this out, see whether you are getting the correct answer or not. This is a very similar question to what we have done earlier in the video. Which graph shows how the resistance of a filament lamp varies with the applied potential difference V as V is increased to the normal operating potential difference. So one thing that you must remember, is that as the voltage increases in a filament lamp, what happens? The temperature increases. As the temperature increases, your resistance increases. So both of them have a which relation? Direct relation. Can you realize both of them have a direct relation? If voltage is increasing, resistance will increase. So B cannot be your option, D cannot be your option, C cannot be your option. A is the only possible curve or the line for direct relationships. The diagram shows a circuit containing 4 voltmeters. The reading on the voltmeters are V1, V2, V3 and V4. All readings are positive. Which equation relating the voltmeter reading is correct? Okay, which equation relating the voltmeter reading is correct? First of all, this V1 will be equal to V2. I can see that V1 is equal to V2 and V2 will be equal to what? V3 plus V4. Simple as that. Are there any options like that? V3 plus, yeah, can you see option D? A very hidden option, a very hidden option. If I take this negative V2 to the other side, it will become what? V3 plus V4 is equals to V2. That is equals to this equation. The answer to 74 should be D. Let me check it out. The answer to 74 is D. Yes, correct. Let's further move ahead. Okay, let's read out this question. In the circuit shown, all resistors are identical. That means all of them have a resistance of R, and R. Perfect. The reading across voltmeter 1 is 8 volts. Perfect. And the reading on voltmeter 2 is 1 volts. Perfect. The reading on voltmeter 2, where is voltmeter 2? Here. This is 1 volts. Perfect. What are the reading on the other voltmeters? Perfect. If this yellow resistor and this blue resistor are identical, and if this yellow resistor is receiving 1 volt, this will also receive 1 volt. The combined voltage across this entire branch will come out to be 2 volts. This branch will also have 2 volts. Hence, voltmeter 4 has a reading of 2 volts. Perfect. So, voltmeter 4 has a reading of 2 volts. There is only one option like that. Wow. This was an easy question. B is your answer. The answer to 76 is B. Yeah. Let's also calculate the reading on voltmeter 3. How will we do that? Although we are not required, we already know it will be 3. But let's do it for self satisfaction. Your total voltage was 8. 2 voltage is occupied by this parallel combination. The remaining is 6 volts. And you have two identical resistors. So it will get equally divided. 3 volts is the reading across the voltmeter 3. B is your answer. Let's further move ahead. Okay, let's see this. In the diagram shows a junction in the circuit where 3 wires PQR meet. The current in P and Q are 1 ampere and 3 ampere respectively. Perfect. In the direction shown. How much charge passes a given point in the wire Y in a time of 5 seconds? Perfect. First of all, you can apply Kirchhoff's current law here, and you can say the current arriving at a node must be equal to the current leaving the node. Let's say this is X. 1 plus X is equals to 3. X is equals to 2 ampere. What will be the charge? Q is equals to IT. Your current is 2, time is 5 seconds. The total charge comes out to be 10 coulombs. C is your answer. The answer to 81 is C. Okay, let's see this question. A 20 volts DC supply is connected to a circuit consisting of 5 resistors L, M, N, P and Q. Perfect. There is a potential drop of 7 volts across L and a further 4 volts drop across N. Perfect. What are the potential drops across M, P and Q? What are the potential drops across M, P and Q? Perfect, 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 perfect. So, first of all, can you see that the battery total is of 20 volts? The battery total is of 20 volts. Yes, perfect. And at the start of the branches, you will have 20 volts here, 20 volts here. Perfect, perfect, perfect. Now, if you realize, you have given 7 volts here in the branch L. You have given 7 volts here in the branch L, or in the resistor L, you can say. What will be the voltage across M? 13. The voltage across M will be 13. This is 7 volts. Perfect. Now let's further analyze it. Analyze what is happening. You can see there are two options with 13. A and D will get cancelled out right off the bat. Now let's say you have started your journey with 20 rupees. Let's say you have started your journey or started your month with 20 rupees in saving. You have given off 7 volts here. You have given off 7 volts or 7 rupees here. What is the remaining voltage at this point? 13 volts. Perfect. If there is a drop of 4 volts across this resistor N, if there is a drop of 4 volts across this resistor N, what will be the voltage at this point? The voltage at this point will be 9 volts. Perfect. Now let's look at the second branch, the one I am highlighting in green. You started with 20. At this point, you have 9 volts at the middle point. How much voltage is consumed by resistor P? 11 volts. So P has 11 volts. C is your answer. Let me check it as well. The answer to 82 is C. Yeah, that's correct. Let's further move ahead. Okay, let's see this. What is the current in the 40 ohm resistor of the circuit shown? You have to calculate the current in this resistor. So, can you draw the circuit in an easier manner? Yes, this is 20 ohm. This is 20 ohm. Those who are smart will already know the answer. Then this is 20 ohm. Then you have an upward resistor of 20 ohm as well. Then there is one resistor connected across these both, that is 40 ohm. Perfect. Can you realize the ratio of this 20 ohm and 20 ohm is equals to the ratio of this 20 ohm and 20 ohm? So this is basically a null point. This is basically a null point. The current across the 40 ohm resistor is 0. A is your answer. Simple as that. Okay, let's see this. 4 potential divider circuits each consist of a battery of electromotive force 9 volts and negligible internal resistance connected to a combination of resistors. Each of the resistors in the circuit have either a resistance of X or 2X. Which circuit has the largest output voltage V? Which circuit has the largest output voltage V? The largest output voltage V will be across the largest resistance because voltage is directly proportional to resistance in series circuits. In which circuit is the resistance largest? In this B. The resistance across the output voltage is largest in B. You have a resistance of 2x here. Hence, the voltage V will be the largest in point B. This marks the end of the past papers of DC circuits. If you have any questions, you may ask in the comments.